This morning I'm going to talk for an hour about a new service from Microsoft called SQL Server Data Services. But before I do that, I want to motivate this in part by a little story. About 2 years ago, I got up out of bed around 7 in the morning, like I do every morning, went to go take a shower, and I turned the shower on, and there's a little trickle of water coming out. And I'm like looking at the shower, thinking I must have done something wrong, and there's this mechanical thing in the wall, I'm pulling it out, and nothing's happening. A few seconds later, my phone starts to ring. My wife's like, honey, it's the neighbors, they're on the phone, they've got no water, what the heck's going on? Now, why would my neighbors call me? Turns out we live in a fairly rural part of Redmond, and we're actually on our own community well. So we've got a little well house in my backyard, and it serves 4 houses. So we rush down to the well house, we go in, there's a huge 1,000-gallon holding tank, and it's empty. That's typically a bad sign. That means there's no water coming out of the wellhead. Anyway, to cut a long story short, it turns out that our well's failing. What used to be a very healthy well is now only giving us about 1 gallon a minute. And it took us about 4 months to go drill a new well and get our water back up. This was a complete pain, right? I like the type of water that I get from my well. It tastes really great. But I want the reliability that I might get from my city utility that supply water to my local neighborhood. So in part, this is very similar to what we're doing with SQL Server Data Services. For those of you that run your own IT infrastructure today, you have your own servers. Have you ever been in a situation where, for some reason, you're out of server capacity? Maybe you're out of storage. Maybe you need to go provision new server rack space within a data center, but you don't actually have any of that space provisioned already. It can often take a little while to get that level of service that you need back up and running. So SQL Data Services essentially in part addresses that problem for you. So what we're going to talk about are the core value propositions of SQL Data Services. What are the core concepts? What are the value that you will get from this service for your business? And how will you approach and use it as a developer? Before we do that, I'm actually going to talk a little bit about the Microsoft platform evolution and how we view this whole space vis-a-vis software and services. So what you see here is a picture that essentially represents Microsoft's platform. And we have a comprehensive server-based offering for all kinds of data. So in the center of the picture here, you'll actually see a taxonomy of the different types of data, all the way from simple blob storage to relational storage, XML storage, and then finally multidimensional storage in terms of data warehousing, OLAP cubes, and services, and so on. What we're actually seeing today is that we offer a rich set of services around these different data types, all the way from query, analytics, synchronization, search, business process integration, and so on. Now, what's actually happening is there's kind of a little bit of an evolution in this market going on. Data services are now actually being added to this picture. So where you previously had all your data on premises or on your local machine, we're now actually seeing a prevalence of data actually up in the cloud. And that means that we have the ability to essentially have islands of information that aren't necessarily connected well together. And what we'd like to do as Microsoft is to take the value proposition and the services that we provide today in our software stack and our comprehensive data platform and offer you the same value that you would get from our on-premises offerings up in the cloud. So a little bit, before we go into the details, I'd like to talk a little bit about our data services vision. So today we have, as I've said, we have a lot of on-premises solutions where you have your data available, typically in a silo. And with ADO.NET Data Services, where there's been some talks at MIX this week about that, it allows you to put essentially a data services head on top of your existing data deployment, thereby making it visible and publishing it to other applications. And we publish that using a set of open protocols. So we use SOAP, REST, and AtomPub and various other open serialization formats. And that means that this data itself is largely self-describing. It's accessible from multiple platforms. You're no longer necessarily stuck within a Microsoft proprietary protocol. You can actually access your data from all kinds of different stacks, whether it be PHP Ruby or a Microsoft-specific stack in general. We're seeing two interesting things happening here. So there's two types of data services. So last week, Microsoft just announced that our existing Windows Live services, for example, Windows Live Contacts, are now actually available with an ADO.NET Data Services head on top of it. And this actually means that you can now start to program to a set of existing Microsoft services using these open protocols and then provide some form of mashup or data services integration solution. We've added another cloud to this picture, and on the left here, we see SQL Data Services. And that's actually the topic of this talk today, which is where you can actually take your existing data that may or may not be on premises today and actually offer it up using open protocols in the cloud. Now, one of the important things about this picture is we wouldn't want these to be islands of separate information, right? It doesn't really help us if we can put our data up on the web, but it's not accessible to other applications. So the thing that actually ties everything together is essentially our synchronization framework. So there's various talks at MIX today and tomorrow talking about the Microsoft Sync framework. And that's essentially a general purpose framework technology that allows you to synchronize between different data stores, whether those data stores exist on premises or up in the cloud today. So to motivate this, I'm actually going to go through an example here. We're going to do a small demo. And this demo is actually going to show the synchronization of contacts between various endpoints. So we've defined 3 endpoints in this demo. We have a simple access database, which is a very simple contact table schema. We have SQL Data Services, which is playing the role of a repository up in the cloud. And we have a vCard provider, which is where I'm synchronizing those contacts down to a simple set of vCard files on my local disk. So the first thing I'm going to do here is I've opened my Access database, and I have a simple contact schema, so first name, last name, email address, and so on. So I'm going to enter a bunch of information in here. And John Jones, our good friend. Okay, now, this is an Access database that's actually sitting on this local machine here. And if we notice down in the tray icon, we have a little application there. And that application is playing the role of an orchestration program. So essentially, this is a process that's hosting the Microsoft Sync framework. And we've configured a sync topology between the Access database to the cloud, and then from the cloud down to a local folder on this same machine. We could, of course, configured multiple different providers, Outlook. We could have done this between multiple machines and so on. Now, what I'm going to do now is go open a web browser and actually go up to SQL Data Services. So this is a web browser that's connected to our REST head. Given that we're using open protocols, I can go query this using my browser. So in REST, if I perform a GET operation over this particular URI, so this is essentially a host name that we've defined for the sync application, so sync mix demo. We've defined a container to store all of my contacts, so Nigel demo contacts. And we're performing a simple query here. So if I go refresh this, you'll actually see that the container is currently empty. Now if I go down to my sync application, and I actually tell it to synchronize, what this is doing now is it's enumerating the local changes from both the file folder that's sitting on my machine and also the Access database, and pushing those changes up to the cloud, and then reconciling any conflicts that may actually be inherent in the data there. So that's actually completed now. So if we actually go and refresh, we can actually now see that we have contacts sitting in SQL Data Services. So briefly, what we have here are 3 entities sitting within our container. And there's 3 different kinds. So we have essentially a sync metadata entity, which is where we're actually storing the knowledge of the sync relationship. What's the version number of each entity, for example? And then we have 1 entity for each of my contacts. Of course, each of those entities has a property for each of the intrinsic properties within a contact. Now, if you remember, we actually had a local file synchronization relationship. So you can see if I go to the folder that I've configured, I actually now have several files sitting here. So I have a metadata file, which corresponds to the metadata entity within the container. This is, again, storing the basic knowledge of the synchronization relationship. And then I have two files here, each file representing a vCard for each of the contacts in my relationship. So let's go and open one of these contacts and actually go make a change, and then we can actually see the flow of the data back to the Access database. So we'll go modify this. Perhaps I move to the East Coast. And I got myself a new cell number. So let me go save this change. Again, we walk up to our sync application. And one of the things I want to point out here is I'm doing this manually so we can actually demonstrate the data flow. It's also possible using your sync orchestration application to set it so that it can automatically synchronize when changes are actually seen. So we go run our sync again. Okay, so it's completed. So let's again go back to essentially our cloud query here and refresh this information. And we can actually see that indeed my phone numbers have been updated in SQL Data Services. If we go back and open our Access database, we can actually see that the changes are already present within Access. So essentially what happened there is the orchestration application opened the Access database locally, pushed the changes into the database, and because Access has the form already open, it actually detects that the underlying data has changed and then automatically refreshed it. So what are the core value propositions of SQL Data Services? So we have a tagline of your data any place, anytime. And what we mean by that is it's continuously available. So if we think about the synchronization scenario, the thing that's really nice about that is you actually have one of your sync partners always available, always on, no matter where you are. You know, of course, you have to have a connection to the internet. And that's actually fairly powerful for synchronization scenarios, as well as a whole host of other business applications. So as you've seen, the fact that I hit that with a browser, it's obviously an internet-facing service. And there's three core value propositions that we have for our service. The first one is really around application agility. And what we mean by that is the service has to be very easy to use, very accessible, very fast to start and provision, and actually start to use the capabilities of our service. The second value proposition is really one about scalability. So if we go back to the analogy that I gave you with well water to start with, that was really a capacity management problem. I needed a certain amount of capacity, and for whatever reason, I actually outstripped the ability of my well to deliver that. If we take that analogy to data and the SQL Data Services, we're basically saying you no longer have to worry about those problems. We guarantee that your capacity that you need will always be available when you need it. So whether you start out storing a few megabytes of information within our service and then running a relatively minor query workload, or whether you actually move to terabytes of information, or you actually take a small amount of information and then suddenly start sending many, many queries into the service. It doesn't matter. Those resources will be available for you when you need them, and you're only going to be paying for the services that you use, right? So for folks that already have their own IT infrastructure today, typically you have a lot of standby server capacity just for when you need it, because when you need it instantly. So we're basically guaranteeing with SQL Data Services that you no longer have to provision that access capacity. We're taking that burden on for you. We're guaranteeing the capacity that you need will be available for you when you actually need it. And then the third factor, which we view as very important, is really that this is a business-oriented service. And by business-oriented service, what we mean is we have a highly available, highly reliable SLA. So we guarantee that the service availability will meet your business needs. And we view this as actually a distinguishing factor in the industry, an area that we're actually going to pay a lot of attention to as we go forward with the service. So this next slide illustrates the basic high-level architecture of our service. And I put this in the deck to really illustrate that we're leveraging a lot of key infrastructure that we already have today within Microsoft. So at the base, we have something called Global Foundation Services. So Microsoft is essentially an internet-oriented business. We have a lot of high-scale services available today. If you go look at our Windows Live brand, our Live Search brand, and so on, there's literally tens of thousands of servers available in many, many data centers around the globe. And those servers and those data centers are actually maintained by something called GFS, Global Foundation Services. So we're leveraging GFS services to go deliver on the value propositions of SQL data services. So we don't have to invent there. We can leverage the knowledge and know-how that we already have. The second layer of this picture is around something that we call the SQL Server Data Services Platform. And this is essentially a platform where we've taken our SQL Server technologies and we're actually layering them on top of GFS, putting them into our data centers. And this is largely the back-end storage and data processing backbone by which we deliver our core internet-facing service upon. And then the third layer is essentially the service delivery pipe, which is essentially the layer that hosts the web service. So this hosts both the SOAP and the REST head for our data service and deals with the basic operations that you'll see as we go through the demos. User provisioning, authority provisioning, container provisioning, and so on. So there's three core concepts within our service. The first concept is that of an authority. So an authority is a unit of geolocation and billing. So by that, we mean that an authority is a DNS name. So you saw from the browser demo that we had a sync host name. So we had sync mixdemo.data.sitka.microsoft.com. So that's a DNS name. And of course, that resolves to an IP address, which resolves to some set of servers sitting within a Microsoft data center. So that it gives us the ability to geolocate your data because we have to pick a specific data center that that host resolves to. Underneath a specific authority, we have a collection of containers. And a container is largely a unit of consistency and search. So what we mean by that is the container becomes the core unit of operation in our service. So a container stores a collection of information inside of it. You query against a container. You add entities in a container. You delete entities, and so on. One of the core values of a container is there's no schema required. So if we go back to the accessibility of our service and the ability for developers to start using it very, very quickly, you can literally provision a container and start using it immediately. You don't have to think about schema design and schema evolution and so on. There's a very, very flexible storage model available here. And then the third concept is that of an entity. And an entity, as you see, is simply a property bag of name-value combinations. And the entity itself is the unit of update and operation. So for example, if I want to modify an entity, change a property, add a new property, remove a property, what I have to do is retrieve the entity, the whole entity itself, make a change to that specific entity, and then push the whole entity payload back up to the service. So we're going to go through another demo now, and this is what I called the Hello World demo. And what we're going to demonstrate here is essentially a simple application that interacts with the service head. So this should give you a better understanding on what the interaction protocol and model looks like, what our simple payload formats look like, and we're primarily going to focus on a REST-based example. So everything that I demonstrate here in this example can also be done through our SOAP service head. There's full symmetry of the capabilities. So you basically pick the protocol that's right for your business use case, and you have all the capabilities of the service available to you. So this is a simple WinForms application that we built. And what I'm first going to do is essentially walk up to an authority that I've already created. So I have an authority called test at our service endpoint of data.sitka.microsoft.com. And if I run a query against that, that'll actually show me the set of containers. So remember, an authority is a parent for a set of containers within our service. So this shows me essentially two simple containers. We have a demo container, and then we have a Northwind Traders container. So let's go through an example of where we create another container. So we go, we've got a little XML snippet here, which is the schema for a container. And we then go create an ID for that. So we call it live demo. And then we go to a post operation. So because we're a RESTful web service, a post maps to a create operation. So if I post this payload to an authority, that's logically saying I'd like to create a child resource of the authority resource, which is itself a container. So if we take a peek at what we actually sent here, we actually sent a request, a post request to our service endpoint. We provided simple authorization. So this is using SSL, so your credentials are actually secured over the wire. And then the payload is exactly the payload that we saw in the upper window. And we actually saw what our response was. If we go take a look, we can actually see that it was actually created for us. Now, if I go query that specific container, so we go hide this little sniff here, we can actually see that we now have a sub-resource beneath the specific authority. So we have a resource called live demo, and it is indeed empty at this point in time. So now if I want to create an entity, I start with another snippet. So this is essentially an entity snippet. I create an ID, and then I can add a number of properties to it. So we can create a whole bunch of other properties and so on. Now again, if I do a post to this resource under the live demo, we'll actually see that again we did a post to the live demo, and this time we took the entity payload, and we got a response that it again said that the operation was successful and that was indeed created. So if we now go and perform a query operation again against that container, we can now see our specific entity. Now if we wanted to make a modification to this entity, we'd first select it. So we now have a resource that is indeed the entity resource. So we've got the authority plus the container ID plus the entity ID itself. We can do essentially a get over that resource to retrieve it. So every part of the three-level hierarchy has a resource exposed for it. And you can operate using a symmetric set of operations against that. So the same way that you create an entity is identical to the way that you create a container, is identical also to the way that you would create an authority. So if we wanted to modify this entity, for example, we wanted to change the name of this property, so stir prop. We change this to John Jones. And perhaps we wanted to maybe remove these properties here and maybe add a new property. And then if I try and do a post, the entity is already going to exist, so we should actually get an error back. Okay, entity demo 1 already exists, so that kind of makes sense. But if we do a put actually maps to an update. We could actually see again that we put to this specific resource, and we actually got success. And of course, the request at this point should be fairly obvious, contains the entity payload itself. So that's relatively simple. Now, if we want to perform delete operations, again, we take a REST operation and we perform a delete against that resource. So if I delete demo 1, it's actually succeeded. If I try and retrieve that entity again by performing a get on that entity resource, we should naturally find it. Okay, so it looks like that worked okay. If we pop up a level and we go back to our container, we now see our container is empty. But if I wanted to delete the container, again, I would just perform a delete against the container resource. So that actually succeeded, and if we try and requery it, we again get the same error message that the live demo entity cannot be found. So that's relatively simple. Now let's go back and take a look at query operations. So if we go back up to our authority, we can enumerate the containers that we have available to us. And then we actually go select a specific container. So I have a container with a snapshot of the Northwind Traders database inside of it. So this is a common example database that we use. And I go query that. You can see that I do have essentially a number of entities inside of this. So these entities have all kinds of different data types. So we have strings and decimals and so on. So let's go take a quick look at what our query language looks like. So in SQL Data Services, the query language that we expose is a variant of the LINQ syntax. So LINQ being language integrated query. So for those of you not familiar with it, essentially in a LINQ expression, you have one or more enumerators. So this is saying for each entity, E, in the target container. So we're bound to the Northwind Traders container. So this is indeed logically an employee, a shipping order, and so on. I'd like to select the whole entity. Now, if I wanted to do a query at this point, for example, I wanted to find entities that were of a specific kind, for example, an employee, I could say e.kind equals employee. So we go run this again. Whoops. E dot. There we go. Nice, helpful error message from our service. And this is actually now showing me all the employees within my container. Now, of course, we can combine other more complicated expressions. For example, we're interested in employees, excuse me, in the state of Washington, state or province, Washington, and perhaps within the city of Bellevue. Now, one thing to note here is there's a set of fixed properties on an entity. So we have kind, an ID. So they're what we call the metadata properties on the entity. And then for the extended properties themselves, because an entity is itself a property bag, we use actually this lookup or dictionary notation. So E is essentially has logically a dictionary associated with it. And within that dictionary, we have a key which is logically the name of the property that you're looking for. So we go run this again, and we actually find that we have one employee who lives in the city of Bellevue within Washington. Okay, so that's what I wanted to show there. So one of the things that I showed in the demo was essentially using a simple REST-based operations against our web service. So this is a code snippet that we actually used in that application that demonstrates what a create entity operation actually looks like. It's actually very simple. So you saw from the Sitka browser, the SSDS browser that I showed you, that the entity payload was a very simple XML format. So this is essentially a method that we use to implement our create entity, so our post request. And it's very, very simple. We actually just create a simple web request operation. We set the type of the operation to be a post. We set the target URI, so the target resource that we're actually operating over. So in this case, it's actually a container. We specify the entity payload, the simple XML payload that we demonstrated. And then we pass simple authorization credentials. And literally, we execute that response, we get the result back, and if the result code is actually okay, we know the operation went through. So this is very, very simple code to write. Very, very approachable, very easy to start using. Similarly, if you use our SOAP head, you can actually walk up to our SOAP service endpoint. You can download or automatically get the WSDL, if you're in Visual Studio, and then we'll autonomously generate a SOAP proxy class for you. And it's extremely simple. So all of the operations that you have on authority, a container, and entity, you'll see symmetric methods available through our web service head for those. So let's go recap some of the concepts that I actually went through in the demo. So an entity is essentially a flexible property bag. One of the core concepts we have in our service is no requirement for schema, right? So that means that there's no concept of walking up to a container and saying, alter this container, add this property. This property has a specific name and a specific data type. You literally just start adding content to the container. So as you actually create entities within a container and you store named properties and so on, they're actually available for you. And we've done a lot of work in our query language to support the dynamic nature of the content that you will actually see within a container. Now, entities also contain some fixed properties associated with them. And today we have essentially 3 core properties. So there's the identity of an entity. So if the entity happened to represent an authority, that would be the authority name. So in the examples that we went through, we were using the test authority. So its authority ID would indeed be test. If it was a container, it would represent the container ID. And then obviously if it's an entity within a container, that's the identity of that entity within its parent. Secondly, we have a kind. So you saw in the examples in the Northwind traders, we had various kinds. We had employees, orders, and shippers. And kind is a property that's stored within every entity, and it's used to discriminate between the different use cases or the different types of data that you have within your container. So you saw in our simple XML format, when you're actually interacting over a REST head, the name of the root element in that payload gets mapped to the kind property. So the example that I went through, where we're actually looking for entities of kind employee, we're actually matching that root level XML tag in our store. Finally, the third metadata property that we have is the version number. And this is actually a service-supplied timestamp. So if you recall the first demo that we did where we went through the synchronization scenario, we're using that version timestamp to understand what's actually changed within a container. So we can use that to reconcile, pick up changes, and actually move them through our synchronization pipeline. That's one case of using the version number. There's also another case, which is where we support simple optimistic concurrency control. So if you've actually performed a fetch operation or a query, and you've pulled content down locally, and then you operate over that content, and you want to post the results, put the results back to actually effect a change in the stored state of that entity, you don't want to actually be in a situation where you overwrite somebody else's change. So we can actually use version as a very simple optimistic concurrency control mechanism. So when you pull an entity down, you know what the version is because it actually comes as part of the entity payload. And when you post the request back, you can also say, I'm making this change based on, say, version number 5. And in our service head, we look at the current version that we have for an entity. And if it's still at version number 5, we let your operation go through. If it's actually at some version larger than 5, we'll actually fail that and say there's actually been an optimistic concurrency violation. And then it's an application's responsibility to reconcile that and obviously make the change. Finally, entities have properties, and all those properties are searchable. So all of the examples that we went through, we didn't actually have to go through any physical database design. We didn't think about, well, what's the name of this property? What's the data type? Does it need to be indexed or not? That's all taken care of for you in the service. So whenever you add an entity whenever you add a property to an existing entity, those properties are automatically available and searchable for you. So here's an example. So first thing to point out here is that within a container, obviously entities can have different kinds. So in this example, we have a car and a fun car. So presumably we're modeling some form of classified listings here. Secondly, each entity, it may have the same property name, but there's no actual requirement that it actually has to have the same type instance. So this goes back to the fact that there's no schema contract required within a container. So you can leverage the same name property in different roles, possibly using different kinds, although there's no requirement from our service to understand a tie-in between a use of a name property of a specific type with a kind. It goes back to the lack of a schema contract. And then finally, you can actually have different properties within entities. So you could have, for example, 2 employees. They're obviously of the same kind. They're both employee. But they could actually have very different properties inside of them. In this example here over the car, we have one property of engine size, which doesn't exist within the other entity. So if you're actually performing a query operation and you're looking for entities with an engine size property, entities that don't have an engine size property actually are treated as if they have a null instance of that property value. Right? So you get null propagation semantics through the query language. The second concept that we covered was a container. And this is essentially a store for flexible entities. It's what we call a unit of consistency. Right? And by that, we mean that it's the largest domain of search and operation inside of our system. So we guarantee that all entities within a single container are logically co-located within our service. So regardless of how much content you have inside of a container, you can always query over it. You don't have to worry about breaking your query up and spanning that across multiple different sets of entities. Again, it also has a unique name inside of its container using the entity ID property. So the final concept is that of an authority. So through our REST service head, this looks very much like a namespace. So because it actually has a DNS name associated with it, we guarantee that all content within an authority, so that is all containers and all entities within those containers, are going to actually be geolocated within the same data center. Now, that doesn't mean, of course, that all of that content is going to logically be stored within one specific server. All it means is they're largely in geographically the same location. So Microsoft has multiple data centers all over the globe. So in the example we went through with our test authority, I happen to know that that test authority is located in a data center in Western Washington, right? All of the containers that I created, my test, my demo container, my Northwind container, they're all within the same cluster deployment of our SQL data service. So finally, the web service API is exposed through both SOAP and REST, right? And why do we do that? Well, we're all about open protocols. So we want to essentially take the core value props that we offer with SQL data services and make them available to you regardless of what protocol choice you want to use. You have very specific reasons about why you might choose to use SOAP or why you might choose to use REST within your enterprise. We wouldn't want that protocol choice to be a barrier for adoption for our service, so we support both. Secondly, in our REST service head, today we support a simple plain XML format. We'll actually end up supporting multiple formats in time. So for those of you that are familiar with the ADO.NET Data Services technologies that we're releasing, you'll know that we're essentially adopting AtomPub, or a variant of AtomPub, through that service head. We'll also be adopting that same protocol through our SSDS service head also. And that means that essentially if you want to embrace the benefits that you get from using the ADO.NET Data Services, they're actually broadly available to you when you actually use our SQL Server Data Services also. Again, we want to ensure that the choices that you make for the development environment, the protocol choice, or the protocol runtime is not a barrier for you actually adopting our overall storage service. A little note about security here. So currently, what we have is that every authority has a single owner. So you noted in the examples, I logged in using a single credential, so a single username and password combination. Once I've actually been authorized to the authority endpoint, that gives me full control over all data stored within that authority. So there's no discriminated rights today. And of course, we've been through the operations on our various service endpoints. So the operation on provisioning an authority. So again, the same example I gave you on actually creating a container and updating a container and deleting a container. You can also do the same operation for creating an authority, right? When you create an authority, we automatically provision a DNS name for you, right? That's all done using exactly the same patterns. So that's one of the things that I actually like about the service. You just have to understand that there's some very simple verbs that we support. We can create an entity, we can update it, we can delete it, and you can take those same concepts and apply them to our service endpoint for essentially provisioning an authority, to an authority endpoint for provisioning a set of containers, or essentially to an entity itself for creating and modifying the entity content. So in line with that, we have multiple URIs exposed for each resource. So we have essentially a URI for the service endpoint itself. So we see data.sitka.microsoft.com. And today, the only thing you can do with this endpoint is actually create an authority. In time, that will be extended to allow you to essentially also delete an authority and then modify additional authority metadata. For example, provisioning user rights assignment at the authority level would be a good example of that. The second level is the authority endpoint itself. And an authority, what we can do is we can fetch it. So because an authority is itself an entity, if we fetch it, we actually get back a single entity which contains the metadata associated with that authority. Now, today that only contains essentially the identity and a version number, but in time, we think it's actually very useful to support the notion of extended properties on entities. So if you wanted to add custom metadata to an authority item or a container item, possibly to mark how it's actually being used in your application, we'll actually be supporting that. I can also query an authority, and what's stored beneath an authority is a set of containers, so that's essentially equivalent to querying containers. And again, once we extend our metadata services for containers, that query could actually be very interesting, right? So rather than using, say, a specific naming pattern to store content within a container, you might actually be able to attach certain properties to container entities and be able to query for the container that you're looking for without really understanding what its absolute name is. At the container endpoint, we can actually fetch the container entity and go through the whole life cycle of modifying its properties. We can also query for the entities within a container. Those were some of the examples I went through in the Northwind scenario, querying for all employees living in Bellevue, Washington. I can update the container, so I can modify the container properties, and then also delete and create entities within inside it. And then finally, the last resource we have available for you is essentially that of an individual entity. So this has essentially got a three-part name or three-part identity. We take the authority ID, we take the container ID, and the entity ID, and that gives you essentially a stable resource that you can program against. And I can obviously fetch that resource, I can modify it, and I can also delete it. So how might I actually build an application using SQL Data Services? So in this example, we're actually going to go through a multi-tenant application. So Litware HR is a web-based recruiting service, and they support multiple tenants. So for example, I might go to Litware and say, hi, I'm Contoso, I'm a web-based startup. I'd like to consume essentially a job listing service from you. And as someone using that service, I can list my open positions, and then applicants can actually then go and apply for these positions. And what Litware is doing is it's using SQL Data Services to essentially provision capacity on demand for new tenants as they actually come online. Now, some of those tenants could be very, very small, and some of those tenants could be very, very large. And the value proposition to Litware is they don't really care how big the tenants are. They know that SQL Data Services is actually going to provide them the capacity they need at the time that they actually need it. So in this example, we have two roles that we're going to cover. The first one is that of the HR manager. So that's someone who is essentially provisioning or consuming services from Litware HR. And then the second one is the role of a job applicant, someone who's actually going to apply for an open position. And what we'll see in this demo is how Litware chose to use the ACE concepts, the authority, the container, and entity concepts. So there's a little cheat sheet here. So we created a single authority for Litware HR. So essentially, logically, they've chosen to use an authority to host an application. So Litware might have multiple different applications. It might have HR management, payroll, and so on. And they could choose to create an authority for each of those individual applications. Secondly, they're using a container for various different use cases here. The first case is for storing the application metadata. Because it's a multi-tenant application, it happens to be a data-driven application. The app doesn't understand what the set of tenants are in the code. It actually has to go query to enumerate those set of tenants. And then finally, for each tenant, we actually create an individual container in which we store individual positions, so jobs that are actually available through the service, and also the set of applicants for those jobs. And then finally, the entities themselves are going to represent individual items, such as a job listing, a job application, and so on. So this is our landing page for the application. So we're going to try it. So I'm playing the role of the HR manager at this point. And I'm going to enter some demo information here. So this is largely so this is where I'd enter my legal name, my alias, and so on. And Litware was also previously built as essentially an application blueprint pattern to show people how they could actually consume, essentially, software and services. So this application also integrates Silverlight streaming, because that was one of the first web services that Microsoft made available. We're not actually going to demonstrate that in that application today. We're going to focus more on how it actually uses SQL data services. So we go provision the application. And what this is doing at this point is actually going in, adding some content into the litware metadata container so that the application now understands that there is now a tenant, mixed demo. And then secondly, it's provisioning a container for the job listings and jobs by that specific tenant. So if we can now go in and we customize the application. And we log in here. So admin. I'm just going to configure the app so it has a look and feel that I like. So we can go configure styles. We can possibly upload a custom style sheet so that when people go hit my specific job portal, they actually see my company logos and so on. And then the first thing I'm going to do is configure the data model. So this essentially, in the example here, we have a single entity type that we deal with. And that's essentially a position. So if I go modify this, we can see we have a set of shared fields in common with every tenant of litware HR. So all job positions have these 3 core fields. And then we have an additional set of things. For example, we add a new field, so available by. It's a type date time. And I add this to the application. Now I go save the entity customization. Now once I'm done with this, what I'm actually going to do is essentially go to the public site. So now I've configured my tenant. And I've basically said all HR users of this system are going to actually see this look and feel, and they're going to have to use this core schema when they actually create new positions. So I now go to the public site. We go to careers, and I'm a recruiter. Oh, I need to log in, of course. And the first thing I'm going to do is create a new job. So we're going to open a position here. And perhaps it's trombone teacher. And we'll go open another position also. Okay, so you can now see we have 2 positions open. We can go see the details of those positions. And then possibly as an applicant, I might choose to apply for one of those positions. So we can go add some demo data in here. And we can now go submit that resume. Is that working? Yep, I think it's done. We go to careers, and we can look at the open positions we have. Whoops, sorry. We can perform a job search to look at which positions are available. And then as a recruiter, I can also evaluate the candidates. Oops, looks like I missed a submission. Let's go take a quick look now behind the covers and actually see how Litware is actually using this. So this was the Litware metadata container that I mentioned that Litware had chosen to create. Essentially, we have a single authority, so Litware HR, and then we have a set of containers beneath that authority. So let's go find where the metadata container is. So it's actually a container called Litware HR. So if we now go take a peek inside of that container, we'll actually see a variety of different entities inside of that container. So I happen to know that one of these entities is a tenant. So if we now look for the MIX tenant, we have a tenant ID here. And I happen to know that essentially this tenant has actually used the tenant ID as the name of the container. So I now go look at that specific container, and we can essentially see the positions that we created. Looks like I neglected to actually save the applicant here. But if I'd have actually done that, you would have actually seen an applicant entity inside of that with an associated position available. So that basically demonstrates how Litware HR used SQL data services. Now, the mapping that we chose on the authority and container and entity is just an example. And Litware, for example, could have chosen to create a single authority for litware.com and then had individual containers to store all of the different applications. And we don't dictate to you how you would choose to layer your application over SQL data services. There's a set of trade-offs available at this point. So for example, the fact that an authority is secured by a single credential may work in some multi-application scenarios when you want to use a single authority, or it might actually dictate to you that you need to create multiple authorities. The choice is really yours as you choose to lay your application. So when can you actually start using SQL data services? So we announced yesterday that we have an invitation-only beta opening up within approximately 2 weeks. And we're going to be onboarding people using an invitation code process. The reason that we're not immediately opening this up is we have to provision capacity as people actually start to use the system, and also start to understand how people are actually going to start using our system. We've obviously spent a fair amount of time ourselves going through application demos and design patterns and so on. But when we release a service out to the wild, I don't think we're going to really understand all the use cases that you guys are going to have in this service. So we actually want to start ramping people up as capacity so that as we see the use case patterns that people are using, we know we're going to be able to offer you a good level of service, even though the service will remain in beta. During the beta stage itself, there'll be no charge for the service. We're actually just very interested in understanding what are the application patterns that people want to use. What level of service do you need to run your business on? What are the capabilities that you actually need? So this is really the first step that we want to take in engaging in a dialogue with essentially the community on helping us shape the service. We want to build a service that's actually going to be good for you, that's very approachable, gives you core value propositions for your business. We obviously have a lot of ideas about the type of capabilities that we think are important. But in terms of the relative priority of those, we're actually going to be using a customer engagement process to help us rank and understand what the next most important feature is. Now, in terms of feature delivery, what we're actually looking for excuse me, is essentially refreshing our service approximately every 8 weeks. So that means as someone using our service, when you actually get accepted into our beta program, approximately every 2 months, you'll see changes through the service head. And that could be higher stability, better performance, increased quota capacity within our service. Could also obviously include new features. For example, richer query support, blob storage support, full-text search support, to name a few possible features. Our goal is to actually release this service in the first half of next year, right? So through this program, we actually start essentially in March. That's actually going to allow us to take our service through many iterations before we actually go live. And to us, go live means that we're at the point that we can actually guarantee high stability, a high business SLA. We understand that what application patterns are important for developers, what capabilities are required, and we know we've pretty much hit the sweet spot in terms of being able to offer a service that most people can actually start using, right? Now, as soon as we go live, we actually start charging for this service. Now, it's very early right now to talk about pricing, but you can think of pricing about charging for the services and resources that you use. So the amount of capacity that you consume in our system, whether that be in terms of number of queries processed or amount of raw storage used through the service head. We're experimenting with some different models right now, But finalizing that pricing model is really going to be a process by which we have to understand what is a pricing model that works based on our costs, because it's obviously costing us to build this service, and what's also a pricing model that works for you, for someone actually consuming this service, and find actually something that works from both sides. So what are the key takeaways that I'd like you to walk away with today? The first one is this is a starting point. So we have SQL Server technology in our service. This is actually a project from the SQL Server division at Microsoft, right? We obviously know how to build enterprise-class database software. We have a very successful product portfolio in that space. But the service that we're delivering is very simple, right? For example, the level of query capability, the security model we have with that service, the fact that it's currently just a data-oriented service. If you compare that to what we have in SQL Server today, it looks like a very, very small subset. Now, we actually want to essentially start small and essentially iterate and figure out what are the capabilities that are important for you. For example, I don't believe that taking SQL Server as is today, slapping a web service head on the top of it, and publishing that directly to the internet is actually a model that's actually going to work for most people. Now, as we go through our process and we evolve our service and our learnings and so on, it's possible that we could approach a large subset of that over time. We just don't know. So we've actually chosen to start simple and then go through this 8-week iterative cycle. The second part is this is built using proven technologies. So we didn't start the project and say, hey, let's go build this web service. Let's go create all this storage and query processing technology. We started it from a core value that said, we have a lot of IP, and knowledge and know-how. We have essentially a very rich set of data server capabilities. How can we take those and essentially take them to the internet market in an internet-facing service such that we can actually build a service that's highly reliable, has good quality, and gives you the capabilities that you need? So that's really about the code and the IP and the service that we have. The other knowledge and know-how that we have is we know how to run services. So Microsoft is essentially a very large company. We have a large internet presence, right? So for example, within Microsoft alone today, at last count, we have over 16,000 SQL Server boxes in our data centers. It's probably the largest SQL Server deployment in the world by my reckoning, right? Now, we know how to run those boxes and keep those services running at high scale and high availability, keeping them highly reliable. So what we're doing is we're taking the two sets of knowledge that we have there, how to build the product and how to run the service, and then we're combining these together to deliver SQL Server data services. And then we will iterate and we'll start to expose richer and richer functionality over time. So there's some resources available for you here. The first one, if you haven't already pre-registered and you're actually interested in our service, you can go to the SQL Data Services portal, and there's a sign up, pre-register for beta link there. Yesterday, our servers were fairly busy. We had a fairly large sign-up rate, so we're very excited. And that validates in part some of the value propositions that we're bringing in this service. There's also that's going to be the landing point that you can find more documentation and in time samples and so on. Now, while you're here at MIX for the remainder of this week, there's also a whole bunch of other activities going on around SQL Data Services. So the first one is essentially a chalk talk. So if you haven't been to the sandbox and the open spaces, I'd encourage you to do that. It's essentially about halfway down the hallway here, turn left. And that's essentially where there's 3 core things going on. The first one, there's chalk talks. So we have 2 chalk talks signed up. So it's essentially a very low-key, very informal discussion with a whiteboard. And we have two chalk talks set up. So we have Thursday at 12, so today at noon, and Friday at 11:30. And those 2 chalk talks are going to talk about 2 things. So today's talk is going to talk about the business value proposition, how we think of this as a business-oriented service. That'll be about 30 minutes. And then the talk tomorrow is essentially going to be a chalk talk around the application developer's view of Sitka. So what are some of the patterns and practices that have emerged? The second activity is the Open Spaces Theater. So that's at 2 o'clock today. And that's where 2 of the developers from the SQL Data Services team are actually going to go through essentially a patterns and practice discussion. So we're going to go through some common questions that you might have as a developer. For example, if you use Java in your enterprise today, what are the patterns that I might use with Java to actually interact with SQL Data Services? If you want to essentially use an XML-centric view of processing our XML payloads, what are some patterns and practices that you might actually use as a .NET developer and so on? So about 6 or 7 small little topics that we'll actually go through. Finally, if you haven't actually seen our hands-on lab, also in the sandbox, a lot of the examples that I went through today, basic interaction, basic provisioning, query, and so on, you can actually experience for yourself. So we have an ASP.NET sample application that you can actually go build. It's on Betty's Antiques or something like that. You can go look at antique listings and so on. And you'll get a feel for how you actually interact with the service using the REST protocols. And you can also start to play with the SOAP protocols too. You can generate a SOAP proxy client and so on. And then finally, I demonstrated here today this Microsoft Sync framework. There's actually a very good talk happening, I think, tomorrow, so T32, where there's going to be a lot more details about the Microsoft Sync framework. So the demo I gave you today was a very, very simple sync topology. They're going to go through in a lot more detail the types of capabilities that are available to you with synchronization. We have a blog. We've started to blog about what we're doing now that we've revealed to the world. So if you want to actually keep up and have a dialogue with the development team, we're actually using a single blog to communicate with the community. And then finally, my email address is listed below. So that concludes my talk. I thank you all for coming, even at 8:30 this morning. And I'll take a few questions before we finish.
Why would I choose this over like Amazon SimpleDB?
So I think the key thing, the way that we think about this is not a simple DB compete, right? Our goal is to take our existing enterprise server products and capabilities in terms of our rich data platform and give that as a service delivery mechanism. So if you compare what we have today with SimpleDB, yeah, they look remarkably familiar. But remember, this is only a start. We already have all of those much richer capabilities in the back end, and they will be brought to the market on an 8-week rhythm and cycle. So we think, for example, 3 months from now, 4 months from now, you go look at what we have, it's going to look very, very different.
Thank you.
Any other questions? Okay, well, thank you for coming. I'll take some questions at the podium if people want to come up later.